Okay, folks, so let's take a look at the data table. This is the data that I got, and from the video, you see that each of the three containers has 50 milliliters of water, which is equivalent to 50 grams of water. They had starting temperatures, and this surprised me because they were a little different, 22.6, 22.6, and 22.0 for the third one. The starting temperature of each metal was 100 degrees Celsius. And then here for column 4, this is actually the change from that starting temperature of 22.6 to whatever the ending temperature was. So for metal 1, the temperature increased by 6.1 degrees Celsius. Metal 2, it increased by 6.4 degrees Celsius. And metal 3, it only increased by 4.4 degrees Celsius. And the mass of the metal, and I rounded just like in the video, the mass of the metal is approximately 58 grams for each piece of metal. So there are all of the pieces of data. I'm going to go over how to calculate the information for metal 1. Right? We are looking for Q, right? The amount of heat that is absorbed by the water. So the energy is going into the water, so that's a positive change. What we're looking for is Q. M is the mass of the water, not the metal, but the water, which if you look at your data table was 50 grams. The specific heat for water, the intrinsic property of water is that it takes 4.18 joules to raise the temperature of 1 gram of water by 1 degree Celsius. So that's where those crazy units come from. And then lastly, that change in temperature, which we said was positive 6.1 degrees Celsius, right? So there's our information for metal 1. And then to solve that, oh, looks like the screen's reversed, but you gotta trust me on this. Oh no, 50 times 4.18 times 6.1 should give us the final answer. The heat is 1,274.9, which really we could round up approximately is 1,275. And our final units are joules. Heat is energy, and joules is a measure of energy. So I hope that helps.